Assalamu alaikum wa rahmatullahi wa barakatuh. This is Said Masur Billah, and today I'm going to present a group project of programming in data science with my partner MD Shariful Islam. Our topic is health insurance cost prediction using two algorithms. One is linear regression and another one is logistic regression. Health insurance is an insurance that covers the whole or a part of the risk of a person incurring medical expenses, spreading the risk over other persons, and this has become one of the important issues to predict how much the cost would be or how much the amount of insurance we can claim from a company. So that's why we have chosen this topic. So the next one that we are going to discuss about is the data set, because for the cost prediction we really need a proper data set to analyze on. So the data set we have gathered is from an insurance company for Bangladeshi citizens, and it has a lot of features, but we have gathered some of the major ones for this project. The independent variables that we have here is the age of the customer, their sex, their body mass indexes, how many children they have got, are they smoker or non-smoker, which region they stay, and then we have the dependent variable, that is the charges. The charges means the predicted medical costs. What is the objective of this project? What are the questions that we are actually interested to focus on? So the first one is, what are the factors that affect the amount of health insurance? So for example, age, does it play a significant role or not? We're going to be discussing about these things in our project, and how precisely the company or the customer will be able to estimate the amount of insurance. So basically we're making this project to help both the customers and the company to predict how much the amount it will be, the insurance amount. The dataset we have gathered was not obviously clean. We had to clean some of the data for the analysis. So we have found out from the description of the data that there are some missing values, and the missing values are 232 missing values. So using the na.amit function, we have removed all of them, and the data is now ready for the data analysis. In this part, we're going to discuss about the correlation analysis. Here we relate both independent and dependent variables to each other. We have only one dependent variable, and that is the charges. The other ones, the other features, for example, age, BMI, children, smoker, these are all independent variables. We will try to relate these things to each other for the data visualization. Here we have two graphs. One is the age versus charges, and another one is the BMI versus charges. In case of the first one, we can see there is a gradual increase of the amount of charges whenever the age increases. So it kind of makes sense. The more older you become, the more amount of money you will be charged. But in case of the BMI, there is no significant raise, and it kind of maintains in the value of 20 to 40. Next, we have another two graphs of sex versus charges and children versus charges. In the first one, we don't see any significant or obvious connection because they are totally kind of independent, the female and the male one. But the only thing we can see is the values are quite dense under 20,000. Then in case of the children versus charges, uh, if if anyone has more than 4 children, the amount of insurance gets lower. Lastly, we have the rest of the two graphs, the smoker versus charges. We can see that smokers have higher charges than the non-smokers because they probably seem to have more medical expenses, more medical health issues. So that's why they will be obviously charged more in this case. And in case of the region versus charges, we don't see any significant changes in any region. All we can see that the values are quite dense under 20,000.
Assalamu alaikum, doctor. My name is Shariful Islam, and our topic is health insurance cost prediction using linear regression and logistic regression algorithm. Thank you, Mashur, for explaining your part so well. So now I'll explain my part. Here we split our dataset into training dataset and testing dataset. So we take 80% data for training and 20% data for testing. And here we try to create one formula where we take age, sex, BMI, children, smoker, and religion as our independent variable, and we try to find out the targeted variable, which is charges. After seeing the data set, uh, we saw that we have independent variable and one dependent variable. So we choose linear regression model to train our data sets. Here is our first model, and for our first model we use the first formula and training data sets. And here you can see the formula, and residuals is minimum is this, median max is this one, coefficients we have intercepts around negative 30,150, and you can see there is three most significant value and one is slightly significant value, which is children, and there is few non-significant value. And we can see that there is multiple R square, which is 74.1%, and we have adjusted R square, which is around 74.09%. And after seeing the p-value, we can see that this is quite good for our projects, because uh, the p-value is quite low. Here is our second formula. For our second formula, we try to reduce the non-significant value, which is sex. So we try our second model and use the second formula and training data sets. So you can see the mean, median, and max, which is almost similar to our first model, and intercepts also similar. And if you see the multiple R square, which is 74.7%, which is also similar, but there is one slight difference in adjusted R score, which is 74.14%. So uh, and we have p-value, which is also, after completing our training with linear regression and logistic regression using two formula and two models, here is the comparison that we get. If you see that uh, in our second model, the RMG value is quite low, and in our second model, the R square is uh, quite high, which is 74.31%. So uh, after seeing the all comparison, we choose the second model as our final model. If you see here, we try to draw one graph using prediction and real value, and after seeing that, we can easily say that the value is quite similar with the prediction value. Now, residual versus a linear model prediction graph also uh, explain that we have the almost similar accuracy, and our model is quite well trained. This is the histogram for residuals. As you can see, if the residual value is 0, it goes the highest number of counts. After seeing the graph, we can say that the error is close to 0, hence we can say that this is the best model to predict. After completing all the training, here we try to test our model. I choose myself to test with our model, so I put my data, and here you can see the healthcare charge for me was 1864, uh, so which is quite good. And you can see that if the person is non-smoker, then his healthcare charge is quite low. So in conclusion, we can say that this project have met the objectives, and we have figured out the uh, features and variables which play vital role in amount of health insurance, as well as the prediction model to help the companies and the customers. Thank you, Doctor. Thank you, everyone.